Hello. Um, so before tamagsugod, let's review these three terms first. Okay, so when you talk about direct proportion, basically like diretso ba? So direct means if one thing goes up, the result also goes up, or if it goes down, then the result also goes down. Examples of this would be, say, for example, number of hours studying, so as compared to your score. So if you think about it, if you study a lot of hours, would you expect your score to go up or down? Of course you would expect your score to go up, right? That's one example. Another example would be hours, number of hours. This hashtag means number of hours working, and also your salary. So you would think that the more you work, the more you earn, or the less you work, the less you earn, right? So whatever you do on the first part will also happen on the second part. Let's do another example. I don't know, maybe um, let's say height and weight. Okay, maybe that's a bad example, but let's try. Okay, so you would think that a person who is taller is expected to weigh more, right? Or if the person is shorter, the person will also weigh less. So basically, you get the idea. The direct is whatever happens to the one variable will also happen to the other variable. Now, what is inverse? Okay, inverse. So obviously, the effect here is opposite. Opposite effect. Effect is opposite. Okay, so what is an example for this? Let's say payment and debt or utang, di ba? So the more you pay, obviously sensibly, the more you pay, the less will be your debt. Okay. One example is number of workers and the amount of work. Okay, amount of work left. Okay, so syempre, if you have more workers to do the work, then each one worker will have less work, if that makes sense. The more or the less number of workers that you have to do the work, then each person will have more work. So the effect is opposite. All right, so I don't know how to say this. Partitive. Okay, so partitive basically means it's divided into parts. Divided into parts. So what do I mean by that? So for example, you have this one whole job, and then you have three people. So let's say Anna, Peter, and John. Okay, and let's say they divided the work into a ratio of 2:3:4. So that means Anna here will get like two parts. This is Anna. So that's Anna right there. And then Peter will have three, one, two, three. And all these three will be Peter's. And then you have four for John. So this four right here will be for John. So as you can see, the whole job, the whole rectangle right here is divided into three parts. One part, second part, and then this one right here, the last one will be the other part. So it's called partitive. Okay, so let's look at your other questions. All right. So in your question here says, read and analyze the problems below, then tell the kind of proportion by writing direct, inverse, partitive on the blank provided before the number. So let's look at the first one. It says, the coach of a basketball team has enough money for 12 basketball players for 8 days. If 4 new members were added, how many days will the money last? So if you think about it, first you have this amount of let's do pesos. This amount of money, right? So let's say you have 100 pesos, right? For example only. And this 100 pesos is good for, no, that's not a good example. Let's say you have 120 pesos. And this 120 pesos is enough for 12 players. So this is good for 12 players. So if you think about it, that means each player would have 10 pesos, right? But then if you have, I mean, 8 pesos for 8 days, right? But if you have more people, what will happen to the number of days? Would you have more days to, just because you have more day, if you have more people, do you think the money will last longer or will last shorter? Okay, so obviously this one right here is an opposite thing. So this is an inverse because, well, the more people to share the money, the less number of days you'll have to, the less number of days for the money to last. Okay. All right. So if 6 notebooks cost $81, how much will 80 notebooks cost? So this one is obviously a case of a direct, because obviously the more notebooks you have, the more will cost, right? The sum of 500 is divided among 3 children. So this is your clue right here. It's divided among three children, and then you're given a ratio. So this is a good example of partitive the ratio. The ratio of girls to boys in class is blah, blah, blah. So you have this, you have a ratio between two categories, and this is the total. This is also another example of partitive. If you see something like mostly you have the word ratio in it, and then you're given the actual ratio and then the total number of people. So that's basically a partitive. Just like this one here, you have total amount in pesos, and then you have the ratio. Divide blah, 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 divide 36,000 into this. So you have that ratio, you have the total. So therefore that is also partitive. 8 men were hired by barangay captain to repair a road for 10 days. So 8 men to repair a road for 10 days. How many days will it take for 5 men to do the same job? So if you think about this, I'm not gonna answer this. So think about that. If you have 8 people to do it in 10 days, what will happen if you have 5 people? Is it gonna go up? Will it take longer or will it take shorter? Okay. All right, so let's move on to the next one. If I could get this mouse to move. Okay. All right. Says here, identify what is unknown in the following: right base, percentage, and rate. Here's the clue. When you see the word of in an equation, okay, the number after that, just before the of, that is your base. So every time you see the of, because of means times. So every time you see the word of, then that means that number after that will be your base. And obviously your percentage would be the one with, the rate is the one with this the percentage sign. I know it's kind of counterintuitive, but the base is, the rate is the one with percentage. Let me see. Let's make sure we got that one right. Where is my? Okay, I can't seem to find it. Okay, so the rate is the one with percentage, and then of course by elimination the other one is your percentage. Okay, let me recap that. That's the if you see the word of, the number right after that is the base. Okay, if you see a percentage, that sign or word, then that is your rate, and by elimination the other one is percentage. Okay, so let's read this. It says identify the unknown and write base, percentage, rate on the line provided before. Okay, so identify the unknown, so whatever is not known. Okay, so if we read this, what percent, so I'm gonna write some sort of like sign here. What percent, so that's a what percent of is blah, blah, blah. Okay, you see this word of, then that means this is your base, 125. Well, this is obviously percentage, and that's the question, what percent? Therefore, this one right here is your percentage. So therefore, the one that you don't know is this. What is the percent? So therefore, you're looking for the rate. So remember, every time you see the word percent, that refers to the rate. Okay. All right, number two, the number 30 is 75% of, you see that word of what number? So this is your question mark, but that question mark is right after the word of. So that's gotta be the base. And of course, 75 has a percent, this is your rate. And this one right here is your percentage. Okay, I can write. Okay, I hope that's clear. After the of, that's where you find the base. All right, Alma allots 18% of her monthly salary to her parents' allowance. Okay, she shares 4,300 to them. How much is Alma's salary? Okay, so well, this is a percentage, so this must be the rate. Her monthly, so of her monthly allowance, so her monthly allowance is what you call your base, because that's right after the word of, right? She shares blah 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 to them. How much is Alma's? So this is the question, how much is Alma's monthly allowance, which refers to this. So therefore you're looking for the base for that one. Okay, I hope that's clear. What number is 25%? So there's a percent here. This is the rate. Well, of 80. So this is your base because that's afterward of. So therefore, what number by elimination, you're looking for the percentage. Okay. Next, 75%. So that's a percent. So that's rate right there of 150. So therefore, that's the base. Is what number? So obviously you know the rate, you know the base, so therefore the number right here is going to be your percentage. Okay. All right. Find the missing what? Okay. Find the missing. That's a weird question. All right. So rate, percentage, base. So the formula here is rate times percentage equals base. Oh, sorry. Rate times base equals percentage, right? And the rate should be in decimal form. So if you look, I'm gonna just set this one up, but you actually do the answer, okay? I'm gonna write the equation here. Rate times base equals percentage. Okay, so this is your rate. So this is 0.2, right? 0.20. This is 0.30. So if you write the equation for number one, you will have rate. So 0.2 times 88 equals, so this is your x right there. That's your x right there. Those are your unknowns, x. So from here, you just have to multiply these two numbers, right? Okay, so now number two, you have rate times base. So your rate is x. You don't know what that is, so probably x is not a good letter because we're using times. All right, I'm gonna call this one r. So r times 80 equals 20. Okay, so the opposite of, I'm gonna work on number two. Okay, so for number two, let me clear that one up. So for number two, you have r times 80 equals 20. So you divide this thing by 80 because that's opposite of this multiplication right there. So AR is equal to 0.25. So that's the rate and percentage, but you want it in with the percent form. So therefore you multiply that one by 100. So that would be equal to 25% if you multiply that by 100. All right, I'm gonna set up number three and you try to answer it similarly with number two. It's very similar to number two. So this is the rate is 0.3. So now rate times percentage equals, rate times base equals percentage. So therefore you have 0.3 times, you don't know that, so I'm gonna call this one B, times B equals 75. All right, so if you want to find B, what is the opposite of times, then you can solve for the solution. Okay, all right, next one is, it says solve the following in a scratch paper, write only your final answer. Which one below? Okay, so let's discuss this one first before we actually answer. And let's try to find out if they're direct, if it's a direct ratio, inverse ratio, or partitive ratio. Okay. All right. So 5 workers can weave 15 baskets in a day. How many workers can weave 48 baskets in a day? All right. So 5 workers can weave 15. So if you have to weave 48, do you think you will need more people or do you need less people if you have to create more baskets? Okay. So obviously you will need more people. So that's a direct ratio. Gabriel, Lemuel, and Lito shared 5,400 pesos in the ratio of, so there is that ratio, you have a total amount. So therefore, this is an example of a partitive ratio. Okay, and I'm gonna show you how to solve that. All right, there are 60 American and Australian tourists in a certain hotel. If 45% of the tourists are Australian, how many are American tourists? So 45% is just like also, this is also a ratio, okay? But I guess this is an example of, I don't know if you can actually, I guess this is sort of like direct, but also some way, somewhat inverse. So we'll not label that, okay? In a class of 48 pupils, only 36 were able to pass the mathematics project during the deadline. Well, okay, so these two problems are similar. Okay, let's answer the first one. If I could get this one to move. All right, so let's answer the first one. It says 5 workers can weave 15 baskets in a day. So from this first statement, there are 2 things that are being compared. So you're comparing number of workers, okay, to the number of baskets. So this is, so I need you to remember that. So your workers is on top and the baskets is in the bottom of your, in the denominator of your ratio. So ratio can be written like a fraction. So if you look at the first statement, it says 5 workers can do 15 baskets, okay? So this is like your notes, okay? This is just like your notes. And then you put an equal sign. How many workers can weave 48 baskets? Well, this is baskets. If you put a ratio right there, baskets, where do you put the 48? Is it above or below your ratio? Well, you know that basket has to be in the denominator. So I'm going to put 48 there. And then the question is how many workers? So that's the one you do not know. So that will be your X, that's your unknown. So now you have what you call a ratio and proportion. Once you have this, you can just cross multiply. So you do, I don't know if you guys are doing that, but meaning you multiply this to like the below, the denominator on one equation, on one fraction, and the numerator on the other. So 15 times x, you have 15x equals, and then you also cross multiply the other side. Like it's like a cross multiplication. Okay, so now 5 times 48, which is, I don't know, 40, 200, 240. Okay, so once you multiply that, maybe I should write that one out. So you will have 5 times 48. Okay, so 15x equals 5 times 48 is, what did I say? 240. If my math is wrong, then just, that's 200, that's 40. So that's 240. Okay, so now this is multiplication in between 15 and x. So you will divide by 15. You'll divide this one by 15. Okay, so therefore the 15 and the 15 will cancel out. You only have x left. And so now you will divide 240 by 15. I don't know what that is. So let's just do by 15. So we'll divide that. So you have 15 and then you have 9, I think. 0, that's 6. So that's 16. So therefore, what does this mean? So X represents the number of workers. You will need 16. You will need 16 workers to complete 48 baskets. Okay. All right, let's move on to the second one. It says Gabriel, Lemuel, and Lito shared 5,400 in the ratio of 1 to 3, I think. Let me see if I can get got that one right. Ratio of 1 to 3. Okay. Okay, so, all right. The clue, when you have partitive ratio, this is actually a very easy problem, okay? So what you need to do is you look at the ratio and you just add X to each one. So that means, okay, so we have, so make sure you partner off the name to the ratio, okay? So we have Gabrielle, Gabrielle, and then you have Lemuel. Okay, I can't even spell. Okay, Lemuel and Lito, okay? So it says here, Gabriel has a ratio for 1 part, Lemuel has 2. So in here, you just basically add X on each one of the ratios. So I'm gonna write 1X here. And for Lemuel, I will have 2X, and Lito, I will have 3X, okay? And so you would say that the total here, the total number of parts is equal to 1 plus 2 plus 3, that's gonna be 6X. So this one here represents the total number of parts, okay? And so now once you get the number of parts, you will write that as a part of the equation. So you will say 6X equals 5400, because that's the total amount of money, right? So therefore we will divide this by 6, we'll divide this one by 6, therefore your X is equal to 900. So this 900, this is 900 pesos, that's one part. So what does that mean? How do we solve for this? Well, Gabrielle have 1X, right? 1X. So therefore that means 1 times 900, which is equal to 900 pesos. That's what Gabrielle has. Lemuel has 2X. So that means 2 times X. Well, your X is 900. So that's 2 times, this dot, by the way, is times. All right, so 2 times 900. So that means 1,800 pesos. That's what Lemuel has. And then lastly, you have Lito, which is equal to 3X, okay? So that means 3 times 900, which is equal to 2,700. And so this is what each one has. So the question is, how much does Lemuel have? Then therefore, this is your actual answer, okay? All right, so let's recap. For partitive ratio, each ratio you put an X at the end of it that represents the number of parts. Add all the ratios and then equate that ratio to the total amount of money. We'll probably solve the other one so that you have more examples of this one. Okay, so let's do the next one. Okay, so what is this thing? Okay, there are 60 American and Australian tourists in a certain motel or hotel. If 45% of the tourists are Australian, how many American tourists are there? So if you have percentage, remember the whole part, let's do the ratio first. So you have American, so you have American, and then you have Australian. There's so many ways to solve this problem, really. Okay, so this is your cheat sheet. Remember, just like earlier, like workers and baskets. So the number on top represents any number that represents American, and Australian, any number that represents Australian, okay? In the denominator. Okay, so it says here 60 American. All right, so well, I'm gonna put 60 Americans here. And do you know how many Australian? Well, you don't know. In fact, that's the one you're looking for. You don't even know how many. So this is the number. And then we put an equal sign. The other thing that's given is that 45% of the tourists are Australians. So therefore, you have 45% here. Okay, you don't really have to write the percent because it's the same thing. And so do you know how many percent are American? Well, you don't know, but you can solve it, because if this is 45%, the total percent is 100%, right? So therefore your American would be 100% minus 45%, because it's only made up of American and Australian. So Australian has 45%, therefore there has to be 55% American percentage. So you're gonna put 55 here, okay? All right, so after this, you can cross multiply. All right, so just like what we did earlier, cross multiply. I'm gonna multiply the one with X first. So you have 55, X equals 60, times 45, okay? And so now I could multiply that one out, but I don't want to because it's going to be a big number. So but you can multiply that certainly. So I'm going to divide this one by 55. So I could get 55 x on its own, okay? And so now I guess in your calculator, you can do 60 times 45 here, whatever that is, and then 55. But for me, because I don't have a calculator, I'm just gonna simplify this using cancellation. So if I cancel this one out by 5, this becomes 9, and this one becomes 11. So now 9 times 60, I have, I don't know, 540 divided by 11, I suppose. That's a weird number. Okay, let me just use calculator because that's not gonna work. So you have 45 times 60. And then you divide this one by 55. Okay, so this is not a good example because they have like 49.09 Americans, Australian. Did I get this one wrong? 60 American. Okay, so this is, what's the question? How many Americans? Okay, so this is a bad problem because obviously we can't have like 49 Americans and a limb or 49 Americans and 2 fingers, right? But mathematically, this is an answer, but it's just a bad example for a problem. Okay, unless I got this one wrong. Let me double check. 60 Americans, 45% tourists are Australians. How many Americans? Yeah, so that's really how it is. Okay, sorry about that. Okay, all right, let's move on to the next one. In a class of 48 pupils, only 36 were able to pass. So this is similar to number 3. Okay, only 36 were able to pass the projects. What percentage of class failed to pass? Okay, so, well, I guess it's a little bit different because you can first find what percentage. So remember, percent, which is like the rate or rate in this case, is equal to the number of failing students over total number of students. Total students, okay? So all you need to know to do is, well, you know that there are 48 students, right? If 36 passed, well, how many failed? So failing students would be 48 minus those who passed, which is equal to 12. So this is the number of failing students, so that we're gonna put that one in here. And so that would be 0.25%, 0.25, that's 1/4. So therefore that's 25%. Okay. All right, I think that's it. Okay, so that's the first page. I will make another video for the second one if it makes sense to me, okay? All right, how do I stop recording?